Question is from GATE 2018 question paper and the question number is 18. The question is, in the decay mu plus going to e plus nu e plus x, what is x? And the four options are gamma, nu e bar, gamma nu mu and nu mu bar. So to know the question's answer, we have to know one basic thing, and the basic thing is that in any nuclear reaction, baryon number, lepton number and electric charge, these three terms should be conjugate. So whenever we can have any type of decay like mu plus is going to e plus nu e plus x, this is obviously a nuclear reaction, and in that nuclear reaction we have to check our baryon number, lepton number and charge. These three should be conjugate. So by that knowledge that our baryon number, lepton number and charge are conjugate, we can have the knowledge about x, that what will be the baryon number for x, what will be the lepton number for x and what will be the charge for x. So now coming to the decay, whatever it is given in our question. So if, as I told you, that the baryon number, lepton number and charge should be conjugate in that nuclear reaction, so coming for at the very first we have to calculate the baryon number for left hand side and right hand side. In that left hand side, the baryon number is 0 for mu plus, because mu plus is not a baryon. Similarly, e plus is also not a baryon, nu e is also not a baryon, and to have the condition delta B equals to 0, we should have the baryon number for x is 0. Now coming to lepton number, this lepton number is nothing but Le, L mu and L tau, any type of lepton. So for that case, mu plus has a lepton number -1, because mu minus is a lepton and mu plus is an antilepton. Similarly, for E plus the lepton number is -1. And nu e is a lepton, that means it has a lepton number +1. So to have the conservation of lepton number, we can have the x value as -1, because we can see that from -1 and +1 it is 0, and in the left hand side the lepton number is -1, so obviously in the right hand side there will be a -1 existence, and the x value, the lepton number of x will be -1. Now coming to q value, so the mu plus has a q +1, e plus has a q +1, nu e is a neutral particle, so it has a q0, and x has a q0, because in the left hand side it is +1 and right hand side it is already given as +1, and as it is a 0, so that means obviously our charge of that x particle should be 0. So from these conditions we can have an idea that x of B will be 0, x of L will be -1 and x of Q will be 0. That means our x will be a neutral particle and it will be an antilepton and it will not be a baryon. Obviously if it is a lepton particle, then it will not be a baryon particle. So whatever the x will be a antibaryon as well as it will be a neutral particle. Now we have to focus the nuclear reaction a little bit more. In the nuclear reaction we can see that as an outgoing particle it is neutrino. So if it is a outgoing particle as neutrino, then obviously it is a weak interaction. In any, whenever as an outgoing particle there is neutrino, then we can definitely say that this is a weak interaction, and in weak interaction there is a specific number of constant is given. That means in that weak interaction each family lepton number should be conjugate separately and independently. So what is the meaning of this? The meaning of this is like mu plus is going to e plus nu e plus x, right? So now L, previously we were talking about L, which was Le plus L mu plus L tau, but right now we will talk about L mu, L tau, Le differently, separately as well as independently. And in weak interaction, as it is a weak interaction because of this nu e as an outgoing particle, we have to conserve the relation that delta LE should be 0, delta L mu should be 0 and delta L tau should be 0. Okay. So these three conditions should be satisfied by that equation, as it is a weak interaction. Now coming to the LE first. For that LE we can see that the mu plus is 0. For E plus it is -1 because it is a electron-lepton family member and it is an antiparticle of that family member. Nu E is +1 because it is nu E, I mean the electron neutrino, and this is the leptonic particle in that electron family. And you can see that from -1 and +1 in the right hand side it is giving 0, so that means X will give us 0. As it is in the left hand side it is giving 0. Now coming to L mu will be -1 here for mu plus, and L mu has a 0 value for E plus, nu E has a 0 value for L mu, and similarly if it is a -1 value, then obviously in right hand side it will be a -1. And for tau case, L tau case, as none of these are tau family members, so each and everyone has the tau value 0, L tau value 0. That means for mu plus it is 0, E plus is for 0, nu E is also 0, and in that right hand side as it is 0 and 0, and in left hand side also it is 0, so automatically the X have a value of 0. So from this equation, from that expression we can conclude that X of LE will be 0, X of L mu will be -1, X of L tau will be 0. So we can have a conclusion that whatever will be the X, that will be a muon type lepton, and the muon type means it will be a anti-lepton. So coming to all, just adding all the conditions, we can have the expression that X should be one lepton and it should be muon type lepton and it should be anti-lepton. So from that figure we can have these options that gamma is not a lepton, obviously that means the gamma condition will not be satisfied. Nu E bar, this is a lepton but it is not a muon type lepton, so that means that condition will also not be possible. Now coming to third option is nu mu. Nu mu is a muon type lepton, that is fine, but it is not an anti-lepton, that means this option will also not be correct. So the last option, which is nu mu bar, it is itself a lepton and it is also a muon type lepton as well as it is an anti-lepton. So that means the correct answer will be D, which is nu mu bar.